Hey, what's up, app mafias? Welcome back to The Commute. My name is Deshkoli, and in this video, we're going to talk about classes and objects. Classes and objects are a very important topic because anything that you want to develop in software world or any kind of logic happens inside of classes or in forms of objects. So classes and objects are the basis of the software development industry. We need to understand them, and they are very important. Let's get started. Let's try to implement a class right here. If you want to implement a class inside of Kotlin, we can use a class keyword, and then we need to type the class that we want. Now, a class usually starts with the capital letter. If you try to make it smaller, it will start to give us error. A class is always supposed to start with the capital letter. Please do not make it smaller because experienced developers will get confused if it is a function or something else. Always make a class capital. Do not make it smaller. Let me give you an example as well. The string class inside of this Kotlin, it's a class as well. As you can see, final class string. Example, this number class, as you can see, it's a number and it starts with n capital. So these are all built-in classes. The string is also a class. It starts with the capital S. Let's make a class of our own. A vehicle class. Let's add variables inside of this class. And let's try to actually understand what is the difference between a class and an object, and why do we even care about classes and objects. Suppose that we want to make a vehicle from a real world object into our software world. Let's understand that. A vehicle might need a name. A vehicle might need an engine state, right? Which is type of string, and our tires of type of int, and we need more. Yeah, that's it, right? Why is it giving me class? It will be a type of class. Now, if you want to create an object, for example a car, and translate that real world entity into a software world, how can we do that? We can do this by using classes. A car is a type of a vehicle. We can use this vehicle as a blueprint to make a car. Let's try to do that. Now we'll say a car, where car is equal to vehicle. Let's name it as Mustang. Let's name the engine state as engine off. Let's say tires are equal to 4. Right. Now the car object is ready. Let's try to print it. What do we have here? Is some kind of Mustang. Okay, Mustang crash generated something. Let's not do that. Let's say print ln. Yeah, it will say Mustang directly. Car.name. Let's try to print one more thing. Print ln car.tires. We can access the values of this particular object called Mustang engine state of engine off and tires equal to. The car here is an object, a real world entity transferred into the software world. Let's try to make another vehicle called bike and translate a real world entity into a software world using a blueprint called vehicle. Let's try to make a bike here. Engine state as engine off, tires is equal to 2. Right. And let's try to print ln bike dot name. What do we have here? Ninja. Let's try to print ln bike dot tires. What do we have? We have 2. As you can see, we can access these name, engine state, tires, all these two are 2 different objects, 2 real world entities translated with the help of this particular blueprint. So what is a class? Class is the blueprint that you use to actually transfer objects which are real world entities into our software world. One important concept that I want to introduce here is, for example, in class vehicle, we have this var right here. What if we try to remove these vars? As you can see, it starts to give us errors. Let's try to print ln car dot name here. It doesn't give us name anymore. Why is such the case? Because the name becomes immutable nature. We cannot access it by default. If we do not make it var, the name will always be immutable. We'll say car.name and it will be immutable in nature. So classes has this property that we need to keep in mind, that in order to access them, we need to make them mutable. using var. Another important concept that I need to introduce here is that what are these two brackets doing here? These two brackets are actually called constructors, and these are the variables that are passed inside of a constructors that can be used inside of this class. Let's make a curly braces and let's try to make a function like engine on, right? Let's try to say engine state. Now it will not be accessible. Let's try to say var here. Now this is accessible. Engine state dot not value. We'll say engine on, right? Now this is the engine on function is present inside of the class, which means it is also present for car and bike objects as well. Let's try to turn on the engine of car using this function, right? Let's try to print this thing car dot engine on, print ln car dot engine state. As you can see, the engine off state from the car turns out to be engine on. This thing becomes mutable in nature inside of this vehicle class. As you can see, it turns out to be engine state is equal to engine on. We can turn on the engine with the help of this particular function, which is available inside of a blueprint called vehicle. Another important concept that I want to introduce is that we can also say constructor in front of this brackets. Now we don't need to specifically say constructor, because let's try to hover over it and say remove redundant constructor keyword. We don't need a constructor keyword right here in order to specify that it's a constructor. It automatically takes it as a constructor unless we try to actually play with the modifiers of it. For example, public. Did I say it wrong? Yep. As you can see, the constructor keyword is now allowed because of this particular modifier. If we try to say private here, again, this is accessible. And as you can see, since the modifier is private in nature, this class cannot be accessed anywhere else. So we cannot create any more objects of this class of type of vehicle. Let's try to make it public. So hopefully this makes constructor and public a little clear. Now let's try to actually understand the concept of secondary constructor in the case of classes. Let's try to make a secondary constructor here. In order to make a secondary constructor, let's say constructor, and as you can see, the keyword is allowed right here. What we have to do, let's say brakes, right? Brakes is something that I want to introduce. It's a new thing that I want to introduce, but I cannot simply just say brakes and be done with it. We cannot just simply make another constructor. If there is a constructor, a primary constructor, and there are certain variables in this primary constructor, we need to actually delegate these variables inside of a secondary constructor. So what we'll do is say this. As you can see, we have a secondary constructor where I've included a new variable called brakes of type of int, and I have initialized all of the variables that are actually present inside of a primary constructor, and we have delegated them with the help of this keyword. As you can see, if I pinpoint on them, it will automatically get highlighted. It means that if I'm using a secondary constructor and if I'm entering the value of the name, it will automatically be assigned to this primary constructor as well. This is what this keyword means. And we can also use brakes here. Let's try to say function engine off, right? And we'll say engine state dot is equal to engine, right? And we can say this dot engine, right? Dot engine state. As you can see, in order to actually find this engine state, we have to say this vehicles this dot engine state, turn it off. This is what it means, right? And this is how the things are used. Let's try to actually use a secondary constructor instead of a primary constructor right here. Now this is a primary constructor usage, and now let's try to say break. uh, 2 bricks. Now this car is actually using the secondary constructor. This car is actually using a primary constructor, right? And in this secondary constructor, let's try to do this and say car dot. As you can see, with this secondary constructor, what we can do is actually give this vehicle class some default values. That's why a secondary constructor is used. We have a vehicle here which has a certain values, which is a certain scenario, and then we have another vehicle here which is like default values, right? And if we look at this car's dot engine state, when we have given the engine state as engine on, and if we try to just print out the engine state here, it says engine off. Why is it so? Because in the secondary constructor, engine off function is called, and on the initialization, the engine off will automatically be called, and it will say engine off, this dot engine state is equal to engine off. It is private to this particular vehicle. It cannot be accessed somewhere else. This is how the default values of the secondary constructor will work. Let's try to actually use car1 dot engine state, and it will say engine off. Let's try to change that to engine on, and it will say engine on, because car1 doesn't call this particular constructor. It will always call this primary constructor, and it isn't calling this engine or engine off functions by itself. Hopefully this makes the secondary constructor and the primary constructor much clearer. Let's try to explore more about classes. One important concept that I want to introduce is called init, initialization block. As you can see in the secondary constructor right here, it automatically calls engine off here. What if we want to make this possible in the primary constructor as well, right? And we will introduce the block called init, initialization block. On initialization of this vehicle class, please call this function. It will say engine off. It will automatically be called on the initialization of the vehicle, right? And if you try to see the car1 dot engine state, where engine on is such a case and we are using the primary constructor, still the engine will be off, because the initialization block actually calls the private function called engine off. Hopefully this makes sense. Can we do car1 dot engine on, and let's see how it goes. Engine off, and let's try to declare it below it, because we try to turn it on, engine on. As you can see, this works perfectly, and this is how the initialization blocks work. Hopefully this makes everything a little more clear. We'll keep on exploring on the topic of classes and objects. For now, this is it, and I'll catch you next time.